Technically speaking, a satellite is anything that orbits something else. So if you're looking at the Earth, then the Moon is a satellite of the Earth. But usually when people think about satellites, they're thinking about artificial satellites, which would be the ones that we make and put into orbit. An artificial satellite would be, well, I like to think of it as a robot in space that we put up there to take advantage of the fact that it is high up above the Earth. In the same way that, standing at the top of a tall building gives you a better view, being in orbit gives you a different or a better view of the Earth. How big are satellites? Wow, they range in size. So Hubble probably is about the size of a bus. A lot of people talk about a lot of satellites being the size of a Volkswagen Beetle. The really small ones might be about the size of a block of cheese, about a kilogram. Those don't do a lot, obviously they're quite small, and they tend to be university satellites. I'd say the average one would be about the size of a small car, although that's just what we call the satellite bus, which is the main part of the satellite where all the electronics and the fuel and everything is. Most satellites in orbit are powered by photovoltaic solar arrays. These are things that take sunlight and convert it to electricity, and those solar arrays have to be big because you need a lot of surface area to capture sunlight to provide enough power for the satellite. So often you'll launch the satellite into orbit and then unfold the solar arrays, and they might be 20, 30 meters long, sometimes more. Probably about the lowest we would orbit a satellite is around about 200 kilometers above the surface of the Earth. So higher than any planes would fly, but still within what we'd call the outer atmosphere. Any lower than about 200 kilometers and they're just too likely to fall down due to atmospheric drag, so they get slowed down by the air and come back to Earth too soon. The upper limit for Earth orbiting satellites, there isn't really an upper limit. I suppose most of them are around 36,000 kilometers would be about the highest we tend to fly them. They're in different orbits because they're up there to do different things. So being in a higher or a lower orbit gives you a different view of the Earth. If you're closer to the Earth, you can see less at any one time, but you are closer, so you can see a lot more detail. If you're a long way away, out, say, at 36,000 kilometers, you can see pretty much one whole side of the Earth at one time, but obviously you're a lot further away, so the amount of detail you can see is less. The other thing is that different heights of orbits have different characteristics in terms of how quickly you move, both over the surface of the Earth and around the Earth, and how much of the Earth you can see. So if I'm in a low Earth orbit, maybe around 200 or 300 kilometers, I'm very close to the Earth, relatively speaking. I can only see a small part of it, but I'm moving over the Earth maybe from horizon to horizon in 5 minutes. Whereas if I'm out at 30,000, 40,000 kilometers, it takes a lot longer to get around the Earth, which means I'm over a particular part of the Earth for much longer. So if I want to spend a lot of time looking at one piece of the Earth, then being higher up might be useful.